to use a chain rule. Actually, there are various methods for differentiation. You can use a product rule. You can use a quotient rule. If you have a product function, you use a product rule. If you have a fraction, okay, that involves numerator and denominator, you use a quotient rule. Okay, once you use another method is a chain rule, which we also call functions of functions. Chain rule is also called functions of type. Rule is the same thing as the functions of functions. We are looking at chain rule. We're looking at chain rule. The first question I'll put forward is, when do we use it? When do we use a chain rule? I'm going to analyze two scenarios. Okay, the first one is when you have, maybe you have y2, when you have an expression, let's say you have 2x plus 5 and the power, maybe power 3. Okay, you have an expression, power 3, power 4, or a fraction. Okay, then you can use your chain rule. If it's power 2 also, if it's power 2, you can use product rule, but chain rule for power 2 will be faster. Okay, so when the power is at from 2 upward, you can use a chain rule. Okay, power 2, you can also use product rule, but that may take time. That's one. So how do we use it? How do we use it? Let's say you have power 2. Okay, we can say let y be equal to this base, this expression. You can give the letter v to power 5, and the v is equal to what? Is equal to this 2x plus 5. Okay, the composite function, which is we call it v. That's the inner function. We call it v. Okay, so in this case now, y is now a function of v. So that will be equal to what? Dy dv. So differentiate this one respect to v. So the 5 will go to the front, and then v, the power minus 1, that's 4. Okay, then this one also is a function of x. So we're going to differentiate the v respect to x, and that will be equal to what? This one, there's no x here. This is a constant, so it cancels 2x. So that will be what? 2. So your dy dx will now be equal to what? Dy dv, whatever you have there, times the v the dx. That's the how to do that. That's the chain. That's the chain rule. That's the chain rule. Okay. For a layman, this the v we can cancel, so you can have your dy dx, dy ds equal to each other. For layman, but we don't do cancellation. Just put your dy dv times what? Dv dx. So that's that on this first method. You can as well use another method. If you don't like this method, you can use another method. And I'm going to explain that one shortly. Okay, so the y dx will be equal to the power will go to the front. Okay, write the expression again, 2x plus 5, the power minus 1, okay, times the composite function, the inner function, ddx of that expression. And that will be equal to, if you differentiate this one, you're going to have 2. So that will be 2 times 2, that's 4. into bracket what? 2x plus 5. Anything to the power 1 is that number. So this is another way you can solve this question, which is even faster. If you have composite function, f of g of x, for this will be equal to, you first of all differentiate the outer function, that will be prime for the answer. Then you keep the inner function constant. Then times derivative ddx, okay, ddx of g of x. So which we can write as a prime, f prime of g of x, okay, and then times g prime of x. If you don't want to use ddx, you can use g prime of x. Okay, so a typical example, I'm going to look for that, and then we are going to apply that. So these are the ways to undo chain rule, which we also call functions of functions. So on this one again, you have the g of x is a composite function, is an inner function, it's a function inside f. So you first of all differentiate the outer one, keep the inner one constant, and then you now differentiate the what? The composite function. Okay, let's, without further ado, let's go to question solving. The x will equal to what? This one will go to the front. Then the expression 2x plus 1, the power minus 1, that's 2. And then times derivative of this composite function. Derivative of 2x plus 1 is what? Is 2. And that's what? 3 times 2, that's a 6 times 2x plus 1 or 2. So here I can just write 2x plus 1 and put a prime. That's the derivative of 2x plus 1, the composite function. Number 2, we have y equal to sine x squared. Okay, I'm going to solve it in 2 ways. The first way is to, we can correspond this to f of g of x. Okay, then correspond it to f of g of x, where the outside function, the external function is sine, and the g of x is your x squared. The composite function is x squared. So this will be equal to what? This will be equal to d dx of sine okay, so I don't want to, so this will be equal to derivative of sine is a cos, derivative of sin is cos of the function, and then times the composite function, derivative of the composite function, and that will be equal to what? If you differentiate this one, that will give you 2x cos x squared. So that's that on that question. As you're coming in, you need to type I. Welcome. Okay. Okay, thank you for coming on board. If you're new, please subscribe to the channel. For this one, you can use product 2 for this one. And if you want to do that, you're going to just split it into 2 parts. But I'm not going to use product 2 because we are not discussing product 2. If you want to use product 2, this will be cos x times what? Cos x. Then you can apply your product 2. You keep one constant, and then you differentiate the second function, and then plus the one you differentiate here, the one you have differentiated, you keep it constant, and then you differentiate the second, the one you kept constant here. That's your product rule. Okay, So if you apply that, you're going to have derivative of cos is minus sine. So it's going to be equal to minus sine x cos x plus the same thing also here. This minus sine. So that will be what? Minus sine x cos x. So if you differentiate that, it's going to give you minus 2 sine x cos x. That's for the product rule. But we don't want to apply product rule. We want to use our chain rule. So I'm going to write this one into this form. That's a cos x. It's the same thing. That's the equivalent of that expression. Okay. Then I'm going to the y prime, which is the y dx. The 2 will come to the front. We come to the front, just like normal differentiation. You just like you have d square. Okay. You're making like d square or t square. Okay. You imagine that this composite function is v. So, and if you differentiate v square, it's going to be 2 times v, and your v is what? Cos x. The power minus 1, and then times derivative of the composite function. Derivative of the composite function, which is what? Let me make it this way. Derivative of the composite function cos x prime. This one is 1, this one is prime. Okay. So, and if you want to use prime, you can use let me clean this one. If you want to use you can use the x of the composite function. So, and that will be equal to derivative of this one is minus sine x. So that will be minus 2 sine x cos x. Anything to power 1 is that number. So that's that on that. Okay. And if you like, you can do efficiency by applying. You can solve it in 2 ways. You can say y equal to v to power 4. And v is equal to what? 3x squared minus 4. Give a letter for the composite function, for the inner function. Then the y is a function of v, and that will be the y, the v. So if you differentiate v to power 4, that will be 4v3. Just normal differentiation. The power will go to the front, the power will go to the front, and the power minus 1. Then v also is a function of x. Then we have the v dx, and that's equal to what? That will be 6x. Minus 4 is a cos times, so it just becomes 0. Then the y, the x will be equal to what? The y, the v, the y, the v times the v dx. The y, the v times the v dx. Then you can begin to substitute now. Please, when you are using this approach, whatever you have there and here must be the same thing. So the y, the v, that's a 4v cubed times 6x. Then you now substitute back your v. Your v is an expression which is a 3x squared minus 4 to the power 3 times 6x. So 6x times 4, that's 24. That's 24, 24x. And that finished the first segment on the chain rule. Okay, I want to say, if you are watching me, I always say it. Take your journal, take your pen, and begin to follow along. Okay, even sometimes some people have already, as I'm solving, they also are also solving the questions. Okay, take your journal, take your pen, and begin to follow along with me. Please invite someone so that we can extend this section. Invite someone, so that we can extend. Yeah. For the one we have on the screen, we have ddx of sine 4x squared plus 3x squared x. The g of x plus 3x. And don't forget the derivative of this one. Derivative of this one will equal to what? Will equal to the external function of the and then times the composite function, derivative of the composite function. So apply that for this one, which will be equal to, you first of all differentiate the outside function, the external function. The derivative of sine is cos of the function for a square, and times the derivative of the composite function. Derivative of the composite, the prime mean d dx, the prime mean d dx of that expression. Okay, and that will be equal to, if you differentiate this one, if you differentiate this one, we're going to have 8x plus, okay, open and close the brackets, and then time mathematics. Mathematics is following rules, following. Then you solve questions, then you become a guru. The more questions you solve, the better you become. Okay, you become an expert in that area. You think fast. Okay, you beat the time. If you are the tough question, you beat the time. Okay, so yeah, next question will be coming in. Cos 2x plus 1 over. Yeah, next question will be coming in. Next question will be coming in. If you have your question, begin to forward it. Begin to forward it. Begin to forward it. Begin to forward it. It doesn't take time. Begin to forward it. If you have question, begin to forward it. Okay. Begin to type your question. Begin to type your question. This one, we have derivative of sum of functions. This is derivative of sum of functions. Okay. And when you have derivative of sum of function, it's going to be derivative of each of the functions. It's going to be derivative of each of the functions. 1 over sine 2x. We're going to do the algebra there. That's the first thing you do. Derivative of sum of functions. Okay, derivative is the same thing as differential coefficients. DDS is called, you can call it derivative. You can also call it what? Or differential coefficients. Differential coefficients. They are the same thing. Differential coefficients. That's your derivative. So the question now is that, how do we differentiate cos? This one, cos 2x. This is a composite function. This is a, we're going to apply chain rule. You're going to differentiate derivative of cosine is minus sine x of the function 2x, and then times derivative of the composite function, the 2x, derivative of the composite function. You differentiate the external function, which is a cosine, and when you differentiate cosine, it's going to give you minus sine of that function. Okay, then let's now do the algebra for this one. When you have 1 over, this is going to be d dx of 1 over sine will give you cosec, which is a CSC 2x. 1 over sine will give you cosec. Notes, please notes. Notes. 1 over sine x, we'll call it cosec x or CSCX. Okay, so if you now have 1 over sine 2x, it's going to be equal to what? It's going to be equal to cosec 2x or CSC what? 2x. Please note that. Take your journal, your pen, and begin to follow along. Begin to follow along with me. Okay, begin to follow along with me. Okay, let's look at the comment section. Let's see what we have there. Let's see what we have there. Thank you, thank you, thank you. I like the comments. Thank you, thank you, thank you, thank you, thank you, thank you. What is? Thank you, thank you. Let me check the question. No, sine 2x divided by. Okay, we are going to take the various version. Don't worry. Let's solve this one. We're going to take the various version. We're going to take the various version. I'm here. I'm here. Okay. I'm going to take the various version of the question. Let me just finish this one. Let's assume this is the question. What I see initially is cos 2x plus 1 over sine 2x. That's what you type. Cos 2x plus 1 over sine 2x. Okay. Let's see the answer to that one. Then we'll now take another version of the question. We'll take another version of the question. Begin to invite your friends. Begin to invite your friends. Invite your friends. Invite your friends. And let your friend also do likewise. Line. Okay. Don't forget to give the videos a thumbs up. Differentiate 2x is going to give you 2. That's minus 2 sine 2x. Okay. Then for the CSC, for the cosec will give you itself, and then I think is it cot now? Cot 2x. Cot 2x. That's when you differentiate CSC. And don't forget the composite function, derivative of the composite function, derivative of 2x. So that's the what? Times 2. So that's that on that case. Let's take another version of the question. Play with identity. Now we're going to play with identity. Cos 2x can be equal to 1 minus 2 sine square x, or 2 cos square x minus 1. Okay. So what we want to do now, we want to find a way of cancelling this plus 1. Okay. Want to find a way to cancel that plus 1. And then sine 2x. But the denominator is equal to 2 sine x cos x. Okay. So we cannot use this one. We're going to go for this one because we want to find a way to cancel this plus 1 here. So let's we're going to do the algebra ddx of 2 cos square x minus 1. That's for your cos 2x. Okay, and then plus what? Plus 1. So this minus 1 plus 1 cancel all over sine 2x, which is 2 sine x cos x. Close your brackets. So we've achieved the targets. Our target is to ensure that at the numerator you just have one item. Okay. The first one will not be appropriate because we want to find a way to cancel the plus 1. So this one, these are 2 cos square x minus 1, will be the right one to use so that it will negate the plus 1. It will cancel that plus 1. Okay, begin to give a thumbs up as I'm talking. Let it be flying. Okay, begin to give a thumbs up. So that's what we have now. Then the 2 we cancel also. So we now have dx of cos square x is a multiple. That's cos x times cos x over sin x cos x. So this one and this one cancel. So we have ddx of cos x over sin x. That's a cot. I'll give you cot x. That's the inverse of tangent. That's inverse of, that's 1 over tan x, which is a cot x. Okay. So the question now is that, what is the derivative of cot x? And actually, they will give you the formula sheets. They'll give you formula sheets. Derivative of cot x. Derivative of cot x. You can check your formula sheets. Derivative of cot x. Derivative of cot x. So most exams always provide the formula sheets for you to use. Okay, always provide the formula sheets for you to use. So derivative of cot x is minus that's minus CSC square x, and that finished the answer. Okay, let's check the response. Let's check the response to that question. Let's check the response to that question. Okay, thank you. Yep. Okay, find y dx when okay, thank you. You're correct. So that's just that. Just check your at the end of your exam sheet. There is always a formula sheet. Check your formula sheet for cot x, which is a minus cosec square x. Okay, from one of the audience online. Begin to forward your question. Forward your question. Please share the links of this video across your social media platform. Share the links of this video across your social media platform. Okay. Where I'm from Africa, but I've traveled to South Africa. Okay. This is an experience and professional. This is a professional teacher. Okay. I've taken different ethnic group, different people, different colors. Okay. Experience is talking. We have the experience to the glory of God. Okay. It's something I've been doing over the years. On Africa. Where are you from, please? Okay. Thank you. Please share the links of this video. I need a large number of people. Okay, that's good. That's good. Nice to hear that. Nice to hear that. I have some friends also from that place when I was in Asia. I have a lot of friends from that